All right, guys, we're going to be talking about exponents instead of roots this time. So, when you're doing something like this, so 2 to the third power times 2 to the sixth power. There's actually a way of shrinking this so that it's simpler to read. Now, the bases are the same, so we're not going to do anything to the base. The base is going to stay the same, all right? So what's going to change is the exponent. When you're multiplying, the exponents only add. So it's going to be 9 at the top. Okay? With exponents, they always do one less what you're doing. So when you're combining like terms, the exponents do nothing because you're just adding and subtracting. Okay? When you're multiplying, what exponents are doing is adding. Okay? When an exponent actually has an exponent, it's just multiplying. So writing these things down, normally they would do this, but when you're dealing with exponents, they go down one step. Okay? All right. So now we're going to be doing this one. Let's do this one here. So when an exponent actually has an exponent, okay, you would multiply. So this is going to be 5 to the 8th power. So we're not actually answering it, we're just simplifying it. Okay, now over here, this is dividing. So same thing. Dividing means that they're going to subtract. So 6 to the 5 divided by 6 to the 3 leaves me with 6 to the 2. Here, now, see the exponents are the same. So the exponents are going to stay the same. And now these are what's going to actually multiply and make 24. Okay. Now, when both are the same, you get to choose. So this actually has two possible answers. This possible answer that I'm about to point out is going to be 25 to the 4th. Now this means I didn't change the exponent, but I did actually multiply the 5 times the 5. Another form of this would be I keep the base as 5, and remember, when they multiply, what do exponents do? They add. This would be 8. Okay? All right, so that's what you're doing here. You're simplifying an expression. You're not actually answering 2 times 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 2. Okay? You're not doing that. You're just simplifying the expression so that it's easier to read. Remember, the thing that changes is what is different. So you see how these are the same? These are going to change. Okay, you see how it stayed the same all the way through? Same thing here. The base is 5, base is going to stay 5. Here, what stayed the same was the exponents because they were continuous. And the top one, the same thing. Okay, the base is the same, so then they stay the same all the way through. Here, because everything's the same, you get to choose what changes. Do I want the base to change, which just multiplies, or do I want the exponent to change, which means it adds? Okay? All right. Now, a new thing that might be new to you is any number, except for 0, to the power of 0 equals 1. So the answer to this is 1. Even if this was 5,000 to the power of 0, it would still equal 1. Now I'll explain that to you over here. So, we know what 2 squared. 2 times 2 is 2. And then if I go up more, that's going to be 2 times 2 times 2. Actually, 2 times 2 is 4. I don't know why I wrote 2. 2 times 2 is 4. Now, 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. Okay? Now, if you notice the pattern going this way, it just keeps on doubling, right? Now, if we reverse, then it would be dividing. So 16 divided by 2 gives you 8. 8 divided by 2 gives you 4. So this answer is going to be 2. And this, if I divide it by 2, is going to equal 1. And it'll work for every number. At some point, you're going to be dividing by yourself. Any number, except for 0, divided by itself is going to equal 1. So, there you go. All right. Let's look at this. Here we go. So 4 to the 3rd power divided by 4 to the 5th power. Now remember, this means that the top is going to be subtracting. So the base stays the same, But now it's going to make a negative 2. 3 minus 5. Okay, so let me write it over here. 3 minus 5 equals negative 2. How do I know that? Well, the 5 is the number furthest from 0, so it controls the sign. So the minus sign is going to be the sign that it follows. And the signs are different, so they're definitely going to subtract. So 5 and 3, when they subtract, they give it 2. So there it is. There's another way to write this without the negative exponent. When you have a negative exponent, it's telling you, hey, I'm on the wrong side of the fraction. Okay, I'm on the wrong side of the fraction. So there is a fraction here. I guess there is, right? There's an imaginary 1 underneath. So if this is on the wrong side, it's going to flip and become 4 to the 2. You see how it has no negative sign anymore? All right, so I'll show you another example. Here's 8 to the power of negative 2. I'm going to write it without using negative exponents. The same exact thing would be 1, 8 to the power of 2. Another example would be, what if it was underneath? That means it's going to end up on top. So now it's just going to be 7 to the power of 3 over 1, which is really just 7 to the power of 3. Okay, see how with negative sign? I'm on the wrong side of the fraction, so I put it on top. But something divided by 1 is itself. All right, now let's do scientific notation. Now, this number here, when you multiply by 10, it moves the decimal point over. So it's multiplying by 10 7 times. So this dot is going to move 7 times. So 9.296. This is where the dot was. Then I have to move it 7 times. 1, 2, 3, 4, 5, 6, 7. Here's my new dot. How many extra zeros did it take to fill that in? 4 more zeros. You see how all the empty spots got filled with zeros? So this answer is actually 9296000. So that's 1,000. That's million. So 92,960,000. So this is the standard form of the number, and this is written in scientific notation. Okay? All right, here we go. So again, this is scientific notation. If you haven't noticed, the exponent is negative. So when you multiply by 10 with a negative exponent, it doesn't move it to the right, making it bigger. It actually moves it to the left, making it smaller. So 7.03, and I'm going to move this dot 6 times to the left. 1, 2, 3, 4, 5, 6. I got to fill in all these spots with zeros. And we're left with 0.00000703. Okay? And that's a standard form. So let's reverse it. Remember, now I'm turning this into scientific notation. Now, scientific notation has a rule. The number in the front has to be between 1 and 10. Can it be 1? Yes. Can it be 10? No. It has to be less than 10. Okay, so it can be 9.9, it just can't be 10. So, here's the dot right now. I know it doesn't exist, but there's a dot right there. Where can I move this dot so that it makes this big giant number into something between 1 and 10? Here, it's still too big. Too big. Nope. Not gonna happen. Nope. There it is, 3.5. If you would have left it here, it would have been 35. That's too big. So 3.5 is your only option. Times 10. Now I'll have to just figure out how many times I moved it. 1, 2, 3, 4, 5, 6. I moved it 6 times. Okay? And this is a giant number, so it's going to be a positive. This one here is a tiny number, 0.0008. So that's going to be, I know the exponent's going to be negative in this one. So where I have to move this dot, this is 0.008. It's not between 1 and 10. 0.08, no. 0.8, no, still just less. There it is. 8 times 10 to the negative. I know it's negative because that's a tiny number. And it's going to be 1, 2, 3, 4. And we're done. That's all 3 lessons.